run it down, make copies. Yes, less than 10 minutes. So it's not super hard, but if you don't know what's going on, you're going to just be lost. So here we go. Jack, what did we decide? Staying after, not staying after? Not staying after. Okay. Did you text your mom off my phone? I think she emailed me. I'm not really sure. Here, let's do that really fast. I'm just going to let her know. Not staying after. Is that okay? Not staying today. She's not going to be mad. Okay. All right. Here we go. We're going to do all of the evens. So I have to determine the nature and the number of the roots. And in order to do that, I have to know the value of the discriminant. Okay. So how do I find the discriminant? What do I need to do to this first? I'm doing all the evens. I subtract 8 and 2. So when I put this in standard form, I actually have m squared minus 2m minus 8 equals 0. Okay? So b squared minus 4ac. b squared minus 4ac. So go away. So b squared, that's negative 2 squared. Oh my goodness. I'm trying to find a marker that works. I'm so sorry. Like a stylus that works. So negative 2 squared minus 4 times 1 times negative 8. Well, negative 2 times negative 2 is a positive 4. A negative times a negative is a positive, and 4 times 8 is 32. So the value of my discriminant is 36. Is 36 a perfect square? Yes or no? It is. Absolutely. So what do we know about perfect squares? Look at your notes from yesterday. If it is a perfect square, what kind of roots are you going to have? And for those of you that have filled out notes, I did not write down the nature and number of roots. You want to add this. So from a perfect square, what do we know? We're going to have two real rational solutions that are unequal. Two real rational unequal solutions. That's what our solutions are going to look like. That is the nature and the number of roots. Two real, rational, unequal. Okay? So now we have to say what the two roots actually are. I have to solve. And that is using the quadratic formula. So the opposite of b, well, b is, I can't see it. B is negative 2. So the opposite of negative 2 is positive 2, plus or minus the square root of, well, b squared minus 4ac is 36. We already did that part. All over 2a. That's 2 times 1. Okay. So I have 2 plus or minus, what is the square root of 36? 6. And 2 times 1 is 2. So that means I either have 2 plus 6 divided by 2 as my answer, or 2 minus 6 divided by 2. So 2 plus 6 is, divided by 2 is 4. And 2 minus 6 is negative 4. Divided by 2 is negative 2. How do we feel about that? Dandy? Not dandy. Who said not dandy? You did not say not dandy. That was you, Parker. Colt's voice isn't as deep as yours. Okay, we ready for the next one? Are we ready for the next one? Yes or no? Okay. You should have been, Colt, you should have done this. Yes. Okay, here we go. Next one. What do we have to do to this? Minus 17. So this becomes in standard form, 8n squared minus 12n minus 17. B squared, that's negative 12 squared minus 4 times 8 times negative 17. So I know that this is 144. Someone grab that door, plus Plus what? No. B squared is 144. A negative and a negative is a positive, so we should be plussing something to that. I need to know what 4 times 8 times 17 is. I think it's 544, honestly. I think it's 544. Thank you. So when I add these two together, I get 688. That's the value of the discriminant. Is 688 a perfect square? We'll just take the square root on your calculator and tell me if you get a nice whole number. Because if you don't, it's not a perfect square. So no, this is a non-perfect square. So let's talk about the nature and the number of roots. This is going to be 2 real, irrational because they have a square root that we can't simplify, irrational, non-equal. Oh, I don't know why I put the equal sign. You know what I mean? Non-equal. I should have left that. I like that. This is the yellow paper that I asked Carter to pass out. Non-equal. Okay. So 2 real irrational non-equal solutions. So we have to put that into the quadratic formula and figure out what our solution is. Well, the opposite of 12, that's a positive 12. The opposite of B, plus or minus the square root of 688 all over 2 times A. Well, A is 8. 2 times 8 is 16. Are you guys okay if I don't write 2 times 8 and I just like do that mentally? Okay. Okay, so we have to simplify that 688. It's even, so the first thing I would do is see if it's divisible by 4. Is it divisible by 4? 688 divided by 4 is? Okay, that gives me another even answer. So take 172 and see if that's divisible by 4. So we said that this is 12 plus or minus the square root of 4 times the square root of 4, because we divided by 4 twice, times the square root of 43 all over 16. I know that 43 looks wanky, but sorry. Okay, so let's see. What is the square root of 4? So I have 12 plus or minus 2, and this is also 2. What's 2 times 2? Okay, square root of 43 over 16. Can I reduce the coefficient or just the constants that are out front? Can I reduce them? Can I divide everything by the same number? I can divide by 4. I'm going to write a little note over here off to the side that says divide by 4. So let's see. 12 divided by 4 is 3. Plus or minus 4 divided by 4 is 1. So I'm just going to write square root of 43 because 1 times the square root of 43 is 43 over 16 divided by 4 is 4. Those are my 2 real irrational solutions. They're irrational because they have an unsimplified square root in there. That's what makes them irrational, right? We can't turn that into a fraction. If you were to put that into your calculator, you're going to get some ridiculous decimal that's just an approximation. Yes. Yeah, this is what you did, nature and number of roots. Yeah. Okay. We ready to go on? Okay. I think we have 2 more that are like this. So talk about this one. What do I need to do to get it so I can put it into discriminant or quadratic formula? Subtract 5p. I love it that you guys are all saying that. So 5p squared minus 5p plus 12 equals 0. B squared, that's negative 5 times negative 5. So negative 5 squared minus 4 times A times C. Okay, so let's see, that's 25. 20 times 12. Well, 2 times 12 is 224. So 240. So that equals negative 215. Someone can check my math, but I'm pretty sure that's right. Okay. So what happens when you have a negative number in your square root? What kind of a solution are you going to have? It's imaginary, right? It's imaginary. So we say that you're going to have two imaginary, and we often call these complex, right? The word complex means it's part imaginary, part real. Two imaginary complex solutions. Two imaginary complex solutions. They're imaginary because we're going to have to pull out that negative underneath the radical. We're going to have to take out that I. All right, so let's find out what our two imaginary solutions are. Let's see. The opposite of B, so B is -5, so the opposite of that is +5, plus or minus. Well, we already know what the discriminant is, so that's going to be the square root of -215 all over 2 times A. A is 5, 2 times 5 is 10. Okay, so we have to see if we can simplify that radical. Well, the first thing I'm going to do is I'm going to pull out my I. Not my real I, but the I. So 5 plus or minus, you guys are supposed to laugh at that. I times the square root of 215 all over 10. So let's see. Is 215 divisible by 4? No. How do you know? It's not even. Is it divisible by 9? No, because 5 plus 1 is 6, 7, 8. 8 is not divisible by 9, so that's not divisible by 9. Is it divisible by 16? No, because it's not divisible by 4. Is it divisible by 25? No, because it doesn't end in a 2, 5, or double zeros. Is it divisible by, let's see, 36? No, because it's not even. It's not going to be divisible by any even number. Is 215 divisible by 49? No, it's not. Just trust me. Is it divisible by 64? No. No. Is it divisible by 81? No. Is it divisible by 100? Yes. No. Is it divisible by 121? No. Is it divisible by 144? No. It's not divisible by any perfect square. So what do we do with that? We just leave it there, right? We can't simplify that anymore. These are your two complex solutions. 5 plus I, square root of 215 over 10, and 5 minus I, square root of 215 over 10. Okay. If you put the square root of -215 in your calculator, what does it say to you? Anyone try that? Try it. Try taking the square root of -215. Tell me what your calculator says. It should probably say, what did it say? Non-real answer. Yeah. Okay. Negative square root of -215. Yeah. Yep. You do second and then x squared. Second and x squared. No, you didn't put that in negative. If you put in the negative, it'll tell you it's not proper. Can't do it. Yeah, not a minus. The actual negative. Yes, it's imaginary. Okay. Number 8. What can we do for number 8 so it's set equal to 0? I love it that you guys remember that. Do you always have to have your quadratic set equal to 0 to solve it? Yes, all of the time. Okay. So b squared. Well, that's -8 squared, which is 64, minus 4 times 8 times 11. Okay, so let's see. That's going to be 88 times 4, so 64. 400 minus 64 is 336. What's 64 minus 336? That's what we're going to get. -288. Okay. Well, that's a negative number. What kind of solutions are we going to have? Is it dripping on you? Okay. What is it going to be? Two imaginary. I'm just going to abbreviate because my pen's being weird. Two imaginary solutions. Okay, so let's figure out what our two imaginary solutions are. The opposite of B. Well, the opposite of a -8 is a +8, plus or minus the square root of -288 all over 2a. 2 times 8 is 16. Oh my gosh. Guys, if you have a hookup with Santa, you just tell him I want a new stylus. That would be so great. Okay, so what do I need to do first? What am I doing first? Perfect square. Okay, so let's see. I have 8 plus or minus I square root of 288. Let's see. So is it divisible by 4? God bless you. Yeah, it is. Is it divisible by 16? Yeah, it is. Guess what? 8 plus 8 plus 2 is 18. So I know that this is divisible by 16 and 9, which means it's divisible by 144. Did you? I love that. 8 plus I square root of 144 times the square root of 2 all over 16. Colt, what is the square root of 144? So this is really simplified to 8 plus or minus 12I square root 2 all over 16. Is there some number that goes into both 8, 12, and 16? 4. We're going to divide by 4. So our final answer is 2 plus or minus 3I root 2 all over 4. Okay, I know those were tedious, but we needed to practice those. Okay, we were not doing very good with that. Okay, now we're on number, I think, 10, right? Okay, number 10. Down at the bottom of your page. So now we're going to do some, listen up, these should go quick. Now we're just going to do some imaginary number operations. Okay, operations with imaginary numbers. I know that I can take a real number and add it to a real number, and I can take an imaginary number and add it to an imaginary number, but I can't add real and imaginary numbers together, right? We know that. Okay. So I'm going to rewrite this just so you can see what's happening inside of all these parentheses. I think the parentheses are confusing. This is really just negative 2x, or sorry, just negative 2 minus I plus negative 3 plus 6I. So let's see. I have the negative 2 and then negative 3 that I can add together. What's negative 2 and negative 3? Negative 5. Okay. Then I have this fabulous negative I and a positive 6I. What's 6 minus 1? Plus 5I. That's it. That's your answer. Yeah. That's all you can simplify, right? Remember, we want the real number portion to come first. Got it? Next page. What are you not understanding, Colt? Ask it. Because if you're not understanding something, someone else might not be understanding it. Yeah, I'm doing every even problem. Okay. Yeah, I did. 10 was at the bottom of the first page, I thought, right? Oh, no, it's not on your guys's? Okay. I thought it was. Okay. Number 12. That's okay. I know he was. Number 12. Colt, we'll go to number 12 and then I'll do number 10 with you later, okay? Okay, here we go. Multiplication. Let's take care of this first. I have 3I times 4I. Well, 3 times 3 is 12. And I times I is I squared. Okay. We're going to take that and we're going to distribute it through this parenthesis. So 12I squared times 4. Well, 12 times 4 is 48I squared. And 12 times 5 is a positive 60. And I squared times I is I cubed. Yes. Okay. What do I know I squared to equal? Yep. And what do I know I cubed to be equal to? Negative I. So I'm going to replace those. So this is really 48 times negative 1 plus 60 times negative I. Well, 48 times negative 1 is just negative 48. And 60 times negative I is negative 60I. Okay, you don't have to be a jerk. I don't have to do this. I can find a ton of other things to do. Are we good with that? Does that make sense? I think that it's really important to remember what I squared, I cubed, and I to the fourth mean. What is I to the fourth? It's 1. Good job. Yeah. Okay. I to the first power is just I. Okay. All right. Let's move on. Number 14. Reagan, you doing all right? I said, are you doing okay? Okay. 4 times 3 is 12. 4 times 3i is 12i. 3 times 3i is 9i. And 3i times 3i, let's see. 3 times 3 is 9. And I times I is I squared. Okay. Yeah, sure. What does this become in the middle? 12 plus 9 is 21. I. Okay. Talk to me about this this I squared. What is that? It's really negative 1. So this really is negative 9. 12 minus 9 is what? 3. Right? Why is I squared negative 1? Well, because we just set up here that I squared is negative 1, right? Because I is the square root of negative 1, and negative 1, square root of negative 1 times square root of negative 1 is negative 1. Right? That was your Friday lesson, and I did that again with you guys on Monday. Okay. Good. Can we keep going? 16. What do I have to do before I do anything else to that radical? Pull out an I. So I'm going to start with negative 6i square root of 112. It's even, so the first thing I'm going to do is see if it's divisible by 4. What's 112 divided by 4? 20. Let's see, 20 is divisible by 4. So what's 112 divided by 16? Okay, so that's fine. What's 112 divided by 16? 7. If it's divisible by 4 and you get an even number, that means it's divisible probably by 16. Try that one as well, okay? So what is the square root of 16? So this is 6i times 4 times the square root of 7. Well, 6 times 4 is what? 24. So I have negative 24i times the square root of 7. You guys see that this is just a product. This is just a multiplication problem. So anything that we pull apart is still going to have to get multiplied together. Okay, sir. Where does the I come from? Okay, do you see that there is a negative underneath your radical? Okay, we can't have a negative under the radical. We pull out that imaginary unit, right? Okay, number 17. Oh, sorry, 18. So what do we have here? What do I need to do first? Take out I. So this is I times the square root of 216. I times the square root of 216. I pulled out the negative. That's how I pulled out the I, right? That's how we get the I. Nope. Okay. Take 216 and divide it by 4. Anyone? Naomi, we're using that yellow paper up front. You might have one on your desk. I'm not sure. Perfect. We're doing all the evens together and I'm recording it. 54. So is 54 divisible by 9, right? So take 216 and divide it by 36. Okay, so this is the square root of 36 times the square root of 6. But what is the square root of 36? So this becomes 6i times the square root of 6. 6i times the square root of 6. Don't let the I throw you off. If that's the only thing that you don't understand, just like go with it and I'll explain it to you. Okay, Trey? It's not hard, I promise you. Carter, is I hard? Understanding how I works, is that hard, do you think?
Yeah, we told him all about it. Like on the way upstairs, he was like, "I do not know what I is."
He's lying.
I swear.
Okay. Next one. Shh, you did the wrong assignment, so that's on you. Number 20. Okay. So what can I do first? I have 6 plus the square root of negative 96. Take out the I. I is real. What is I? Let's just write this out for Trey. This is the same thing as saying the square root of negative 1 times the square root of, let's see, 96 is the square root of 16 times the square root of 6. 16 times 6 is 96. But we cannot take the square root of negative 1. Why? There is no number that we can multiply by itself to get negative 1. We have this like quandary in math. What do we do with it? Well, we said that the square root of negative 1 equals I, the imaginary unit. Some mathematician created it and we've used it. So I really have 6 plus I times 4, because the square root of 16 is 4, times the square root of 6. Well, I need to have the coefficient, or the real number has to come first. So this is 6 plus 4i. It's no different than saying x times 4. We write it as 4x. 6 plus 4i times the square root of 6. So what we're doing is anytime we see a negative underneath a radical, we know that that was a product of the square root of negative 1 times something, and we know that that equals I. So anytime we see a negative, we pull out the imaginary unit. That's what we're doing. For those of you that don't understand it, this is the third time I've taught that. That's what we're doing. We have to pull out the imaginary unit. Otherwise, none of the laws that we have for math work. We don't deal with imaginary numbers. We only deal with real numbers. We have to pull out the imaginary part. Got it? Okay. That is 6 plus. That says 6 plus. Doesn't say 6 times. It says 6 plus. Do you see that? So 6 is still being added to whatever we have. Okay. Number 22. It says 8 minus 4i times 8 minus 4i. So 8 times 8 is 64. 8 times negative 4i is negative 32i. 4, that's a negative 4 times 8 is negative 32i. And negative 4i times negative 4i, well, negative 4 times negative 4 is positive 16. And I times I is I squared. Perfect. So can we combine like terms? Thank you, sweetie. Can we combine like terms? What two things can I group together? What is negative 32 and negative 32? Negative 64i. What does this become? This positive 16i squared. It's not negative 16i squared. It's just negative 16. So 64 minus 16 is 48. So, not 48. I think it's 54. What is it? My brain is tired. Someone tell me what 6. Thank you. So I have 48 minus 64i. That's your final answer. 48 minus 64i. I took 64 minus 16. Because what is I squared? So 16 times negative 1 is negative 16. Next one. So why don't you pay attention and stop like being crazy? Come stand by me so I can explain it to you. My brain power will transfer to you. Come here. Come on. It'll be fine. Yeah, come on up here. What is 3 times 4? 12. What is 3 times 6i? 3 times 6 is what? 18i, yeah. Plus 18i. So now I'm going to go across the bottom. I have 9i times 4. Well, 9 times 4 is? 36. So plus 36i. think of it just as the variable x. Think of it just as the variable x. We can all fit up here. Okay, so just an x. And then I have 9i times 6i. What is 54i squared? I'm going to wait for my partners up here to get caught up. Colt.
Not all caught up.
I'll fill those out with you. Colt, what is I squared? I squared equals what?
-1.
Yes, so this is really 54 times -1. Colt, what is 54 times -1?
-54.
So when I combine like terms, I have to take 12 minus 54. What is 12 minus 54? -42. And I can combine these. 18 plus 36 is positive 54i. Is that you, Zach? Making the duck noise or whatever? Are we farting over there? What's going down? Okay. That's all right. It's not us. We ready? Okay. Questions? Does this make sense? Okay, let's try it again. All right. So this is double distribution, right? You have to distribute twice. Do you want me to try this with a factor box? Would that make sense? Like if I tried the box, do you guys want to see that?
Yes.
Okay. So I'm going to put 2 and positive 4i. And I'm going to draw my fabulous box here. And I'm going to do 2 and negative 3i. All right. What is 2 times 2?
4.
What is 2 times 4i?
8i.
8i. Okay. What is 2 times negative
-6.
3i?
I.
Negative
-6i.
6i. And what is negative 3 times 4? And I times I is I squared. Yeah. Okay. Let's pull out what we have. We have a positive 4.
That's at the end.
Hang on a second. It's not at the end. What is negative 6 plus 8?
2i.
2i. And tell me, what is negative 12 times negative 1? So I can add 12 and 4 together. What does that give me?
16.
So 16 plus 2i.
That's the answer.
That's your answer.
That was way easier.
You like the box?
Yeah, I like the box.
Okay,
That was
then
way
we'll do
easier.
the last 2 that are like this with a box, but I don't think we have any more that are foiling. Okay. This one we'll do like that. Okay, bud?
Okay.
Okay, number 28. Let's see. We learned on Friday, and then I taught you again on Monday, that when you have a power of I, remember that I works in like a circle, right? In units of 4. 1, 2, 3, 4. So if you take this 27 and you divide it by 4, you get a remainder of 3, which is the same thing as I cubed. What does I cubed equal? It equals negative I. So I to the 27th is equivalent to negative I. I to the 27th is equivalent to negative I. Draco, I want you to look. Were you here for this, Draco? Shh. I'll make a copy of this for you.
I was not.
I'll make a copy of that for you as well. Yep. Okay. So that was your Friday lesson, right? And then we did it again on Monday. So let's look at number 30. So the first thing I want to do is I want to figure out what I to the 37th power is. I know I'm going to take whatever that is and multiply it by negative 6, but I need to figure out what 30. That means it's to the 1, right? So this is a remainder 1, which means I to the first power. And I to the first power is just I. So what is this? What is negative 6 times I?
-6i.
Negative 6i. Okay. Okay. Just leave it on Will's desk. I'll grab it. Okay. Number 32. So look at what's happening here. Look at what's happening. You have a negative 4 minus 2 times I to the 18th. Well, 18 divided by 4 leaves me with a remainder of 2. That means it's I squared. Tyler, what does I squared equal? I squared is negative 1. So I really have negative 2 times negative 1. So that gives me negative 4. And negative 2 times negative 1 is? Okay. What is negative 4 plus 2? Yeah, so this final answer is just negative 2. Okay, next one. Almost done. Okay, we're going to do a box with this one. So draw a box. Okay. Draw a little box. Doesn't matter which binomial we put on what side. Nope, it does not. So I'm going to do 3 and a positive 2i, negative 6 and a positive 3i. Negative 6 times 3 is negative 18. Negative 6 times 2i is negative 12i. 3 times 3i is positive 9i. And 3i times times 2i is 6i squared. Where do you get negative 6?
Because isn't I squared negative
Oh, it is, but we're going to do that when we pull it out. So write 6i squared in your box, and then when we pull it out. Okay, so my first term is going to be negative 18. And then I can combine these two right here on the diagonal. What is 9 minus 12? So negative 3i. But Tyler, what is 6i squared? That's really what?
negative 6.
Negative 6. So negative 18 and negative 6 give me negative 24 minus 3i.
Makes sense.
Okay. Are we good with that? Okay. Next one. I'm going to do another box because it's just that term squared. When we square it just means we multiply it by itself. So I have a negative 3 and an I, negative 3i. Who can fill the box out for me? 9. Keep going. Yep. Okay. So let's see. 9. What's negative 3i and negative 3i, Trey? Okay. And what does I squared equal? It equals negative 1. So what's 9 minus 1? 8. 8 minus 6i. 8 minus 6i. Last one. Last one. Oh my gosh, what the heck is this? This is the only one that you guys have like this. This is the only one that you have like this because I couldn't figure out how to do it in the program I was using. So I couldn't figure out how to write it anymore. And once I got it done, I stopped. So let's just do this one together. So I'm going to draw my arrows nice and slow. I have to take 3 times the square root of 2 times the square root of 2. So let's just do this. What is the square root of 2 times the square root of 2? So that's 3 times 2. That's what that first term becomes. All right. Now I'm going to take 3 square root of 2 times negative I root 2. So 3 times negative I is?
Negative 3i.
Okay. And the square root of 2 times the square root of 2 is just 2. Are we okay with that? Who said no? Who said no? If someone's not okay with that, say it. Okay. Next. Negative 3i times the square root of 2 times the square root of 2. So this negative 3i and the square root of 2 times the square root of 2 is just 2. Why? Well, because the square root of 2 times the square root of 2 is the square root of 4, but the square root of 4 is 2. That's why that works. Okay. Now we have negative 3i square root of 2 times negative I square root of 2. So negative 3i times I is, or times a negative I is a positive. A negative times a negative is a positive 3i squared. And the square root of 2 times the square root of 2 is 2. So let's simplify this. Let's see. 3 times 2 is 6. Negative 3i times 2 is negative 6i. Negative 3i times 2 is negative 6i. And 3i squared, well, that's negative 3 times 2, which is negative 6. What happens to my 6's? They cancel each other out. So I'm left with negative 12i. Negative 12i. Sir.
Can you do one of the problems on the left that has like division?